G'day viewers, this is Troy from Troy's Visual Arts channel. I've now got my AC power supply almost completed. I only have to pretty much rivet the front plate on and she's all ready. So anyway, in the previous video I might have showed you that I've put the on-off switch in there and I've stuck the fuse holder in there to stick a fuse in. So that's now all done. I've put a 4 amp fuse in there, and yeah, I've been for the past hour or two finishing off the front panel, and I've wired up all the AC output leads to several sockets. So here's the front socket face. So the top two sockets, we've got center tap 10 volt output, so we've got 10 volts, 0, 10 volts, and that'll total up to about 20 volts. Over this side we've got 240 volts, 0, 240 volts, which totals up to about 480 volts. Well, it's actually about 500 volts, so I think I'll have to fix it up there. So actually I think it's 250 volts. So yeah, 500 volts AC output total. Now, I've actually put the earths for the 250 volt output, 500 volt output I actually put the earth to the right side rather than to the center tap. So, because it has to be like that for the oscilloscope video monitor, for the way the circuit is set up for the high voltage AC, high voltage DC circuit. So yep, the earth is that pin there rather than the center tap 0 volt pin. And for the center tap 10 volt AC output, the earth is in the center. Anyway, the other outputs are on the right side. We've got 6.3 volts, which is the heater voltage, and 5 volts. And on the left side we've got 4.3 volts and 42.5 volts. Those three outputs won't be used for my oscilloscope tube TV. These three outputs will be used for it. But yeah, I've because the transformers have got extra AC outputs, I decided to add them anyways in case I use them for other applications, as I've mentioned in previous videos. Anyway, let's fire this power supply up and get some voltage readings. What I'll actually do is stick my camera phone up here to just read the multimeter readings. I have to put it a bit higher. I'm just setting this phone camera on a few items. Anyway, we'll fire up and get some voltage readings. So the first one I'm reading will be the center tap 10 volt output. So from center tap to, we've got 10 volts, and the center tap to the other winding 10 volts, and across the two 10 volt windings we've got 21.5 volts. Now the output below will give me about 4.3 volts, or maybe a bit more. It's just a bit of a bit tricky to get these probes into the socket, but yeah, I'm getting 4.5 volts, close enough. And the one below should give me about 42.5 volts upwards. I'm actually getting about 44, roughly 44 volts. Anyway, close enough as mentioned. Now I'm going to go over to the other side. I'm not going to check the high voltage output yet. I'm just going to do the two smaller ones. The one at the bottom will be 5 volts. So stick the probe, jam the probe into the socket. We're getting, yeah, about 5 volts. It's a bit dodgy trying to hold it in there, but yeah, we're getting 5 volts. And the one above will get 6.3 volts. Or something near it. And then checking the high voltage output. So I'm going to measure from center tap to one of the windings. We get 245 to 250 volts. The fluctuation is pretty much due to these bloody lead having difficulty keeping these probes steady on there. But yeah, we're getting close to 250 volts from center tap. And then from across the two windings, outer windings, we'll be getting 500 volts. Perfect. So yep, that's the AC power supply fully operational. Now I'm just going to rivet it all together and she's ready to go. Oh yes, I've also put an earth tap there to connect the chassis of whatever device I'm using to the chassis of the power supply. Anyway, I'm going to rivet this all together and I'll make another little video of it all connected together. Stay tuned for the next video. This is Troy from Troy's Digital Arts channel signing out.